Okay, good morning, good afternoon, good day in general, regardless of your time zone of origin. I have a privilege and pleasure of introducing our next speaker in the Pearson session, Izabela Krysińska.
Hello, everyone.
Isa follows the fairly common career path. She's a software developer, a computer scientist who discovered in herself an interest, an avid interest in data science, and she pursues this interest not only as a data scientist in Pearson, but also as an academic. She's pursuing her PhD degree at Poznań University of technology. So, Isa, the floor is yours.
Okay, thank you. Today I will talk about the topic of data annotation. The main goal of my presentation is to show you that you are probably too optimistic when it comes to estimating an accuracy of your data annotations. And if you have never wondered how good is your data, it means that you have no idea how accurate is your model. I will start my presentation with an introduction to the data annotation. I will show you some examples and stress the importance of high quality annotations. Then I will discuss the subsequent stages of annotation process. Next, I will go through some methods that help us identify mislabeled data. And finally, I will show you some examples of mislabeled data in popular benchmarks. The majority of machine learning applications these days are powered by supervised models. It's still the most effective approach for ML solutions, but supervised models cannot learn by themselves. They highly rely on human work. In other words, on data annotations, which is a process of labeling raw data like text, audio, video, images, so that it becomes training data. Typically, the task of data annotator is to assign a class to an image or select some objects in a photo or transcribe audio. And because building high quality models requires large volumes of data, non-technical humans become an important component of machine learning process. Some services like Siri or Alexa work so well because annotators have spent thousands of hours providing data for a model to be trained on it. Thus, it should come as no surprise that the global annotation tools market size is expected to reach $3.4 billion by 2028. And rising investments in the self-driving market, health sector, e-commerce sector are expected to drive this future demand for the data annotation market, which is a sign that it's worth taking a closer look at this topic. In psychology, there is a theory commonly known as Maslow's hierarchy, comprising a 5-tier model of human needs. And needs lower down in the hierarchy, physiological needs like food, sleep must be satisfied before individuals can attend to needs higher up, like job security, friendships, and so on. You can transfer this concept to the data science world. If you want to solve a supervised learning problem, we cannot jump directly into implementing fancy machine learning algorithms unless we didn't accomplish the bottom stages of the pyramid, which is data collection, data pipelines, data exploration, and finally, data labeling. In this presentation, I will focus solely on this stage, data annotation. And we all know the phrase garbage in, garbage out, which means that the quality of a training set determines the quality of a model. However, many decision makers tend to underestimate the resources needed to curate a training data set. And actually, not only them, scientific community focus mainly on bettering network architectures. You can find thousands of machine learning courses online, but only few show you how to create the training data. In academia, we usually test our brand new algorithms on the old data sets. We rarely need to create data set from scratch. In the industry, it's quite opposite. You often use old algorithms, but on a new data. And that's why I think that the ability to conduct a successful annotation campaign is crucial. You might think that there is no rocket science here, but I found out that very often it isn't as straightforward as it seems to be at the first glance. For example, let's say that we want to perform annotation to solve object detection problem. We ask annotators to color pixels with pedestrians, and we received two annotations visible on the slide. As you can see, annotator A decided to exclude the bug, whereas annotator B decided to color the bug. What should we do? Should we color half of a bug, or ask an independent reviewer to solve this conflict, or maybe we should update guidelines with more precise instructions? We clearly see that disagreement in the bug exists, but eagle eyes probably also noticed that annotator B marked a slightly bigger area of a woman's skirt. Is this also disagreement, or should we accept such a difference? The bad news is that there are no simple answers here. In the next slides, I will show you some approaches to overcome mentioned issues. So without further ado, let's see how the annotation process can be defined. We can split the annotation process into a few phases. The first phase is a deep understanding of project requirements. The best idea is to start with a core team to discuss a problem, boost annotations with answers, and after that go through the answers to check if the whole team understands the problem in the same way. As a result of these discussions, you should produce a run-through dataset. The run-through dataset is the dataset that we are sure is correct. It will be our gold standard to measure annotators' trustworthiness. At Pearson, we often cooperate with our linguists, educators, and phoneticians. And last year, we were working on automatically generated activities, and we wanted to make sure that our learners will be provided with the best quality and appropriate content. So we ran a campaign. Essentially, we asked a few linguists to decide whether they would like to see this generated sentence in an app or not. And we received poor agreement between annotators. So we wanted to discuss their answers one by one. We asked our colleagues to argue their choice. It turned out that the annotators, one of the annotators often disagreed with others, but her argumentation of choice made the rest of the annotators change their minds. And such discussions should lead us to the second stage, which is guidelines creation. In this stage, we need to decide what kind of workforce we need. In-house experts, contractors, or crowdsourced workers. The type of workforce you need will depend on your task, on its scale and urgency. If you have a simple task and you need the data as soon as possible, crowdsourced workers should be the best option. However, if your task requires special qualifications, you need contractors or experts. And very often you can combine different types of workforces to solve your problem. Then we need to choose a tool that satisfied our needs. I was amazed at the importance of annotation interface. We had a task of assigning categories to an audio. There were a lot of categories, like 50 or so, and these categories could be grouped into 5 super categories. And we got a lot better results when subcategories were grouped into 5 categories in a drop-down list than displayed one by one as a single list. So conclusion here is that you should take care of annotation tool UX. Next step is to create instructions, which should be deadly simple, ideally 1-2 sentences. Showing some examples annotated by experts should be also useful, and tasks should be atomic. I always have a temptation to ask annotators multiple questions in a single task, because I like to have a lot of data. And recently we were preparing a speech annotation template. Basically, we want to know if speech is on the audio is intelligible or not. And I told my colleagues that we should ask annotators to transcribe the audio, and also ask them how easy it was to understand it, and also add an extra question about the native language of the speaker, so that we might conclude that speaker has a strong accent. And let's add this and that. But I realized on time that if we will add all my questions, it will be a total disaster, because it's better to run multiple annotation campaigns than ask annotators to do multiple things in a single annotation campaign. All right. The third stage is quality control. To assess quality of our annotations, we can calculate a couple of metrics. First, we can calculate an accuracy of each annotator by comparing annotations with ground truth data. Let's assume that we have diagnosis data set with 5 possible labels and answers from 3 annotators. We can calculate the accuracy of each annotator by comparing annotators' answers with ground truth data. We want to find % of correct answers for each annotator. And annotator A gave 2 good answers from 5, annotator B gave 3 good answers from 5, and so on. However, what if annotators simply guessed randomly for each annotation? They still have a chance to correctly choose some labels, right? So what we want to do is adjust the accuracy according to a baseline of random chance guessing. What is the chance of random guess in our case? Well, we can say that we have 5 labels, so the chance of guessing is 1/5. But if we have strongly imbalanced data set, probably better idea is to normalize accuracies with % of the most frequent label. Yeah. If you don't want to be fooled by high accuracy, better calculate chance-adjusted accuracy. Another useful metric is inter-annotator agreement. The majority agreement is an example of inter-annotator agreement metric. which is calculated as a fraction of times when a person agrees with the majority. This metric is extremely useful for identifying annotators who misunderstood the task or didn't have required qualifications. And you can calculate majority agreements by creating a matrix in which you put the percent of annotators that agree with you, excluding yourself. For example, as an annotator A in task 1, everyone agrees with me, so I will put 1 in the first cell. In the task 2, I've selected a personality disorder label, and only a half of the annotators have selected this label, so I will put a half in the second cell, and so on. Then I can calculate the average from column to get an agreement with the majority score. Then we can calculate per task agreement. We can get it by selecting a max from a row in a task 1. We have perfect agreement, so there will be 1. In task 2, we have 0.5 agreement, etc. Per task agreement is perfect for identifying items that need to be reviewed by an expert. Finally, we can calculate dataset level agreement by computing an average from per task agreements. And this is a very naive approach just to present a general idea, but you should probably use more advanced statistics like Krippendorf's alpha. But I won't explain the maths or formulas here because there is a great spreadsheet created by Robert Munro where you can uncover exact formulas and understand what is going on under the hood. But if you don't want to go much into details, you can check out IRR package that implements various coefficients of inter-rater, reliability, and agreement. All you have to do is pass matrix with annotators' answers to a function. And the last step, annotations aggregation, where we have to combine multiple annotations into a single label. First, we need to calculate an uncertainty for each label, choose a threshold of uncertainty we can accept, and then decide what to do with the data above this threshold. Let's start with uncertainty. Let's say that each annotator has accuracy of 0.9. We want to calculate the uncertainty for task 2. The chances that annotator choose wrong label are 0.1, and we will distribute this probability to other labels. So annotator A selected in the first row. Annotator A selected the first label, so we put there 0.9 and distribute remaining 0.1 chances on the other labels. We can calculate the confidence by dividing a sum of values from row by a sum of all values from probability matrix. The uncertainty can be calculated as a difference between the top two confidences. In our case, uncertainty is 0.71. We need to set a threshold of uncertainty that we can accept. And let's say that this is 0.65, which means that we cannot accept the label for task 2. So what can we do with this task? We have a couple of options. We can assign the task to an additional annotator, or ask expert for review, or exclude the task from dataset. but we obviously want to avoid the third option. Okay, we know how to create a high quality training set from scratch, but how can we measure dataset quality if we want to use dataset that wasn't prepared by us? There are at least several methods, but I found this one very interesting, dataset cartography. The authors propose a great method that allow us identify data points that are easy, hard, or ambiguous to model. And this is calculated based on the metrics from collected during training, such as variability, models variability of confidence across epochs, and models confidence in the true class. And once we know the variability and the confidence score for each data point, we can plot it, creating a dataset map. A color of data point indicates fraction of times when a model gave correct answer. Intuitively, data points with low confidence and low variability are hard to learn, and points with high confidence and low variability are easy to learn. For us, the most interesting points will be points that are hard to learn, because there is a high chance that these points contain mislabeled data. And this method is great because identifying annotation mistakes in a large data set can be highly expensive. And here we have it as a byproduct of the model training process. The implementation is available on GitHub, so you should definitely check this out. Okay, now we have reached the final part of my presentation. Why my trust in ML benchmarks has been recently undermined. Last month, my supervisor have showed me a paper which describes another method that helps identify mislabeled data point named confident learning. The authors found out that there are likely at least 100,000 label issues in ImageNet. They analyzed popular datasets not only to find wrong labels, but also to guess the correct ones. It turned out that even in relatively small dataset like MNIST, they found wrong labels. In C400, at least 6% of test examples are mislabeled. In QuickDraw, at least 10%. And this shows that even the most popular datasets are not error-free. Such errors can make a significant difference in the accuracy, and we use them to compare performance of our algorithms. So it is good to have in mind that no dataset is error-free, and it's good to know how to assess the uncertainty of our model's accuracy. Here I've listed resources I've used to create this presentation. If you want to dive deeply in the annotations evaluation, I highly recommend you to look at the first position, human in the loop, especially chapters from 8 to 10. And that's it. Thank you so much for your attention.
Izabela, thank you for this fantastic talk. We have a few questions from the audience, so I will start with them. So first question is, how do you create a ground truth data set? In many of this annotation task, it seems like a very challenging thing to do.
Yes, that's a good question. I didn't explain how to create ground truth data set because of time constraints, but a strategy you will choose for creating ground truth dataset is crucial because it is the cornerstone of our evaluations. If we failed to create ground truth data, all our quality estimation will be more optimistic than in real life. Essentially, you have to consciously sample data points. Ideally, your ground truth data should be representative. Maybe get sample with the same distribution as data you expected to have on production. Additionally, from my point of view, it's good to include edge case examples. For instance, those you discuss the most with your core team or with the highest disagreement. Yeah, but short answer here is that the sample should represent the data you expected to see on production.
Thank you very much. So I want to expand on that. So in many cases, in many cases, we employ annotators who are highly specialized, but with a slightly with a different background. And in these cases, they are defining the truth as two totally different things. If you, for example, asking physicians about interpreting some results depending on the specialty, they can, for example, assess something with a severe risk or for example, only a mild risk. From the business perspective point of view, how you are selecting the most appropriate annotators for the task?
From the business perspective, we usually have our core team that for example, let's say that we want to assess quality of speech or intelligibility of speech. On the board, we have phoneticians that can provide us with the literature or actually the way that we can measure intelligibility. So we basically rely on our educators and our specialists at Pearson.
Thank you very much. And we have a very brief question. Do you consider specificity in comparison to accuracy?
Once again,
do you consider specificity in comparison to accuracy?
Specificity. Do you mean? I think that I cannot really understand the question. Is it that task is subjective or?
No, we mentioned specificity as a performance measure. Accuracy is one of them, and specificity is considering the fraction of.
Oh, specificity. Okay. Yeah. Okay. Yeah. So basically, we focused on accuracy. We didn't measure the specificity.
Okay, thank you very much. And unfortunately, with this question, we need to wrap up the stream. Izabela, thank you for this great presentation, great talk, and putting in us a bit of skepticism regarding the benchmarks. I thank you all for participating in the stream, and you will be forwarded to the next talk in the Pearson session. Thank you very much, and see you around during YR 2021.
Thank you.
Okej, jesteśmy po streamie. Izo, bardzo Ci dziękuję.